So what we're doing here is this machine, well, not this exact machine, because they'll be building my machine over the next month or so because they're so far behind because it's such a popular machine. So this is how the new hone is going to work, and it is probably more awesome than I'm even thinking here. So because this is actually the first time that I'm actually even looking at this thing live.
No, basically this thing's all been programmed and set up so it knows where all our board locations are. So I'm just going to hit move 1 real quick here. It's going to go over to hole 1 there.
So how do we set hole 1? How do you set the hole?
So do you want me to show you in this video?
Yeah.
Okay. So hole 1. So if I haven't set this up where it's going to be, say it's there and whatnot. So I'm going to go ahead and I'm going to use, I got green buttons, which are big button movements.
Okay.
Depending on where we're trying to go. And I got blue buttons, which are fine hand wheel movements,
okay.
Right? So what we're going to do is we're going to go ahead, we're going to hand wheel over about to where it should be. I'm going to hand wheel my Y back. I'm going to bring my Z up, get the Y back a little more. Z down.
So you're basically just it doesn't actually like indicate in the board because it doesn't need to, because the spindle has a little bit of movement here.
Absolutely.
We just need to get it close over the top of the center of that hole.
Yep.
And then that'll set our WCS for number 1.
Exactly. We'll set our zeros on our Z, our X, Y, and Z on this machine. Okay. Your machine will only have the Z.
Yep.
So we're down in the hole. We're not exactly that well centered right now, but we can get there. So the first hole is kind of important to get close because that's going to be from where we're going to be times in that basically per hole. So if we're off a little bit here, we're going to be off on all the holes. So we want to be pretty close with the first one, but all the other ones, they're going to follow a line basically.
Okay.
So I'm going to go ahead and I'm going to hand one of these stones out a little bit to where we're... to where now that they're sticking out a little bit, I can see if I need to go forward or back, basically, what directions need to go.
Yeah, so you're hand wheeling the stone out, which is really cool. So like on the CV616, like what I have, it's still mechanical. You're turning this wheel up on top of the machine and it forces the stone out through there. But we'll talk more about this stone and how it sizes here in a minute. So this is all setting up so we can move on. So we'll do, basically that's how you set up that first bore, and then you're going to program in what the bore spacing is on the other bores.
Yep.
And then it automatically, when it gets done honing, it goes over to the next hole, which is like super cool.
So we got our block clearance here, which tells us because of our torque plate, from where we zero our stones, we actually got to come up 7 inches to clear our torque plate.
Yep.
And then we're going to go down and basically this thing, so right now technically I'd re-zero all that. We're pretty much there. If you look at the DRO, 20 thousandths, 10 thousandths difference. And then basically this is a small block Chevy. It's 4-4 spacing. So somebody's just put these really nice round numbers in here for us already. Yep. So technically, even though I'm down in that hole right now because all the right stuff's in there, I can hit move 2, comes up out of the hole and goes to hole 2. And so, and I can do the same thing on any of these right now because it knows where it's at.
So how far does it pull the stones in? So it must pull the stones in so it can go over and hit and send the other one.
So initially when it's finishing that hole, it only comes off that hole about 10 thousandths until it gets up out of the hole. Then it sucks them in all the way close, basically.
Okay.
So more or less, I don't know what that distance is, but a decent amount. And so we always try to use the small set of holders to make the hole as well, because there's going to be, usually there's 2 stone holders. Do I have? There's no open holders here, of course.
Oh.
But this is our second hone head we have set up with our 600 grit CBNs. And when I'm saying holders, I'm talking about these guys here. So this is your stone holder.
Oh, and this is all diamond. This is CBN.
This is your CBN. This is 600 grit CBN. This is what we would use to plateau.
This is 600 grit stone, right? Well, it's not stone. Sorry.
Carbide.
Yeah, that is. So this basically never wears.
So this is very hard. It wears quicker than your diamond will. But how many strokes are we doing when we're plateauing? We're only doing 10. It's going to last as long as your diamonds, probably.
Yeah.
Because we're not doing that much work with it.
Right.
Really, right.
Yeah. So this, let's see. So this whole head here, would have the diamond stones there. This just has a finishing plateau hone. But so I'm fascinated on how this is sizing automatically.
Okay. So this is gonna size automatically after we get everything set up.
Okay.
So basically, it knows where hole 1 is. Let's go ahead and set 0 basically, so the stones know where they're at. I'm gonna get back down into that hole. It knows where it's at, so I can confidently hand wheel down in there. And I'm gonna go ahead and I'm just gonna hand wheel these out until they're touching the wall real quick.
Okay, so you bring the stones out until it's just touching the wall. It's got a little bit of force. Does it have a load meter up here so you know what that's?
So right about there is what you got. Go ahead and jiggle that a little bit. So just a little loose in the hole.
Okay.
And then what we're gonna do is I'm gonna hit bead stones to diameter. So right now it's slowly expanding those stones while spinning.
So I hear, yeah, so you can hear it. What it did is it's expanding the stones, and all of a sudden you can hear it go,
yep,
and grabbed it, and it's knowing where it's at.
So now I just zeroed my stones. So if I put in, I don't want to take anything out right now, we're at ground 0 here. So now the machine, because it really doesn't know, it doesn't care if that's a 4-inch bore or a 10-inch bore. All it knows is how much we want to grow the hole. So
okay.
I just learned where we're starting from. Then I'd throw my bore gauge in, say your operator leaves, what, 4,000s, 5,000s when he bores it.
Okay.
We'll say 4,000s.
Okay.
So my first move on this machine, if my boring guy left me 4,000s to work with, my first move is going to be to take out 3,000s out of my first hole.
Okay, so if what if well, we're not going to have any missed bore sizes because we're getting that machine over there. But if my guy did miss the bore size, and so if this one was 2,000s bigger than this one, it doesn't go in and re-zero each size, does it? It's going to take this size, this final size it goes to, and just put that final size over here, regardless of what it starts at. Okay.
Exactly. So
Okay.
if you're within 1,000, 2,000, you're not going to have any problem. If you're saying that hole didn't get bored at all and it's a 10,000ths difference, you'll want to zero on that hole first, whatever hole that is.
Because it will go in and hit it pretty hard.
Exactly.
But it doesn't give a crap about 1,000s or 2,000s. It doesn't care.
And so basically we're fed stones to diameter. We're at 0. We'll pretend we just took out 3,000s because we don't want to spend 3,000s here waiting for it.
Yep.
We bore gauge it because we came off a boring bar. We're gonna have fractured metal in there. It might have taken out 2.9. It might have taken out 3.1 instead of.
Okay.
And so let's say it took out 3.1. So we need to take 9 more tenths out of this hole. So because we're growing this hole till size, the new number in this, I've already taken out 3,000. I just can't say 9/10. I got to say 3,000 and 9/10. So that number's always going to be a growing number, right?
Okay.
All right. So then I'd hit cycle start. I'd let it do this hole, and then I'd bore check it. And if it's exactly what I want with my bore gauge, then all I'm going to do is I'm going to turn off this hole, and then I'm going to let it rip, and it's going to do this. It's going to repeat that exact same size for all the holes.
Gotcha.
And so that's how we get our final size.
Gotcha.
And basically, just for the video, we're just going to ask for maybe 2/10, just so you guys can see it go hold the hole automatically.
So we'll see it go hold the hole here. So we're going to pretend that it's going to find the final size.
And now we're going to hit cycle start. Okay. It's going to go back to where it was. I apologize.
If you... Oh, yeah.
So right there, it's doing the slow Z crash detection. So if we went down there and we hit any web, it would pop up and it would say Z crash detection.
Oh,
Okay,
yeah. So it's automatically doing crash detection. So that's one of the things in a manual machine. Knocking stones off of off the holder sucks. So that's nice. So it's going down. It's automatically seeing if it touches something on the bottom if you missed it.
Exactly. That's all based off your spindle load, your Z load. So if it peaks anything on your spindle, or when you're spinning, or your Z, if we told it to go a little deep, it's going to say Z crash detected. That'll save your diamonds, your stones, your holders, your hone head, and it's going to do that on every single hole.
So it's already done doing that 2/10, and now it just goes over the next size, feeds out, and does it over on the side over here. And it's going to be straight, because part of the deal with anything that's a stone is the stones wear, and as they wear, they start tapering. Shoes and guides start tapering as they're going up and down the hole. So the diamonds do not taper. It is cutting material, or it's not running. I mean that's it. It either cuts it straight or it has no other option other than cut it straight.
The diamonds are awesome, and it takes a really long time. You got to be doing something wrong for a long time in order to make them taper. But if you're doing something wrong for a really, really long time, you can cause them to not be straight.
Really?
But in a perfect world,
That would be hard.
No, like I said, I have customers that don't understand honing principles, basically, and they're not ever getting their lower overstroke right.
Yeah.
And so if I let this machine only go out the bottom a 1/4 inch on every block for 6 months, eventually I will taper the bottom of the stones.
All right. Oh, all right. Really?
Because the machine's going to be short. It's going to be short stroke with gap out the bottom. It'll give you a straight cylinder. It'll give you a straight block for 3 months or 4 months while it's sitting there short stroking the bottom to compensate because you're not going all the way through the bottom. But it's going to be at the expense of your diamonds. They're going to slowly start tapering. And so it's important we get the right information in there, and diamonds will stay straighter a lot better.
Yep.
But if we're not feeding the machine the right information, we can't taper diamonds.
Okay. Also, so what grit stones, or what do we do for stone grit?
So right now we're running a 170-200 grit, and then the CBNs we already talked about, those were 600 grit CBNs is what we're currently running on.
There's only 2 stones?
Yeah, we're not doing a 3-step process or anything. So basically, this we have straight grit diamonds that are say 170 or 140, but the ones we're currently running right now are a blend between 170 and 200 is what we're running right now.
So there is the guys at Rottler work a lot with the Total Steel guys on ring finishes and the crosshatch. So there's a lot of stuff going on here. So one of the things that it does in the crosshatch is a pivoting machine. It tends to, let's see, it goes fast through the middle and slow at the top at the bottom. So the crosshatch isn't perfect. Here, it's perfect. Oh, is that a profilometer?
No, this is the camera to show you your process. So we'll go over here. Actually, real quick, come up here. We were asking for a 35-degree crosshatch, right? So I can come in here, and it's going to rotate the block. Let me get my hand out of there for a second. Sorry. I'll come over to this one right now, and you can see we are
it's like
very.
the camera.
And I can even take a picture of that, and I can save that and give it to the customer if I wanted to.
Wow, that's cool. So it has this perfect crosshatch all the way up and down, and you can control the crosshatch, and then you're also controlling the actual RA finish of that hole better because of these diamonds. So there's a lot of little issues with stones that I'm super happy to get away from, and that's just super cool. I mean, that's neat.
It really is.
So it's only a 2-step process. So we finished to what size with this grit?
So we're going to go right to size.
Right to size.
So wherever you set your zero on your board, on your dial gauge, that's where we're going. And then your CBNs, we're really not taking anything else out. All you're doing is changing the surface. I challenge you. I mean, unless we're doing something like 50 plateau strokes, you're never going to see the amount you're taking out with your CBNs. Because if you're doing 8 to 12 strokes with 600 grit CBNs, you might see a half of a tenth, maybe. And you got to really search to find it, really.
So I think the other thing that we're seeing here too is I had a couple questions or people ask about heat in the block and et cetera from honing. That is a metric crap ton of coolant going through there.
Synthetic coolant.
Synthetic coolant. So that's cold, and then when you don't have a whole bunch of load because you're not standing here trying to rush your way through honing this thing because you're there for freaking ever, and you're putting a lot of load on it, and stones make a lot more heat, I think, too. So this thing is, it's stone cold.
You can touch any one of those boards, and they're all gonna be the same temperature.
So that's helping to keep, after this moves out of here, Yeah, I mean, that's stone cold.
You can't even tell the difference.
Can't tell the difference. So that's making things much easier, because a lot of things that we have to do with the current setup is we hone it, and then you let the thing cool down. You come back and the thing's a half thou tight because it got temperature. And we would always, the normal process is to hone this hole, then hone this hole, then come back. You know, you're trying to space it out so it doesn't get heat. Here it doesn't care because it has way more coolant, way more cooling, more controlled pressure, and better cutting.
Yep. Your coolant cools a lot better than oil, basically. Imagine that.
Yeah,
a coolant cools.
Yeah.
And then, so that's awesome. And then when we go ahead, and you got guys that tell me they got to wait a half hour to plateau a block because they got to let the block cool. We don't need to do any of that. I can literally clock that other hone head in here right now, and as soon as we finish this last hole, and it would go through and plateau the whole block, and you don't need to wait a half hour for it to shrink or anything. Because what we measure right here, right now, is what we're going to measure in 10 minutes. It's what you're going to measure in an hour, tomorrow, the next day, whatever.
Nice.
So you hone to the size you want, and then you go ahead and you give it however many plateau strokes.
All right, cool. So we're gonna, after this hole is done, we're gonna put the plateau hone in there and then compare the surface finish, or just to look at it. We can look at the surface finish there.
You can look at it. You're not going to be able to measure it. You might be able to visually see a difference.
Yeah.
It's going to be very small, but we can do that if you like.
Yeah, I'd like to.
Yeah. No problem.
All right, so we should be done with this hole in just a couple seconds here, and we'll show us how he swaps the head. But if you knew how excited this makes me, because there is what we're trying to do is get away from. There's a lot of things in the machine shop that are feel oriented, and you have to feel it, and you have to understand how the machine's working, which is fine, for the exception of it takes a long time for people to get a feel of how things work and what it sounds like and what it's working like. This is set the number and let the machine do the work. So I mean, that is just fantastically more productive than what we're doing right now. So they're gonna swap this head out real quick.
So all you gotta do to change your hone head is you twist the quick release, that comes out. We're gonna set that one down, put that over there. I'm gonna grab this one, thank you. And click. And you got your CBNs ready to roll here.
We're gonna do here real quick before we just swapped over, or just showed you, just swapped over to the CBN. I think it's called it. You call it CBN?
Yep,
CBN plateau finish. So what we'll do is we'll look at the surface finish. So, and you gotta remember, this is highly amplified surface finish. So you're really seeing everything that's going on there, but it's very uniform, which is pretty important.
Yep.
And you can't get with the older school home.
all right.
So that's what the surface finish looks like. Now we'll run the CBN and we'll take a look at it.
So you want to do the other bank as well and watch this, or do you want to just do this bank and then we'll cut and watch?
Yeah, no, we'll just go and look at it right now.
Okay. We'll let it do these last two. We'll check that.
Just ran the plateau hone over it, and we're going to put the camera in there and just kind of show you that the surface finish difference. Which I like that quite a bit too. I mean, that's neat. Yeah.
So it does look a little bit smoother. Again, this isn't super magnified, but it's got a little bit better magnification than you can see on a phone.
Yes. Yeah. The main thing you're looking at the camera for is just to verify the crosshatch. But it's interesting to see that I can see it and I can feel it too of the surface finish that's there, and that's a pretty normal plateau finish. Plateau, long story short, plateau finish. Plateau means that basically you have little peaks and valleys. It knocks the peaks off. That's a plateau. So it knocks the peaks off, leaves the valleys. Valleys hold oil. Peaks would only ruin a ring. So that's why you plateau finish hole.
Exactly.
Yes.
So the deeper the valley, the more oil retention, basically.
Yep.
And like you're saying, we don't want to have too tall of a peak because that's going to be wearing on your ring.
Wears on the ring.
And the rings are going to ride in the or the RK, excuse me, in that medium area, basically. And so it's definitely important. People are asking for all kinds of different crazy surface finishes these days. But yeah.
So wrapping this thing up because it's getting a little long. But I'm pretty fascinated by this deal because I'm super excited to get it. Go backwards just a little bit. There's nothing wrong with starting out with the old CV616. I did. It's just a matter of graduating up, and we want to get things better. And this is a awesome machine. It is expensive. Everybody understands why we need to start out with something smaller, and you can do a good job. It is very labor intensive to use a CV, and it's good, but this is better. So we're gonna wrap this thing up. I want to thank you, Scott, so much for showing this. I'm looking forward to getting my machine, and we're rocking and rolling.
All righty.
All right, thank you.
Yep.